Choosing your optional subject for the UPSC exam, it's probably one of the biggest decisions you're going to make. I mean, it can literally shape your entire journey and even your final rank. So today, we are diving deep into one of the toughest, but maybe one of the most rewarding choices out there: physics.
So does this one decision really define your rank? It sounds a little dramatic, I get it. But when you look at the numbers, you start to see just how critical this choice is. This isn't just another paper on the exam. This is a potential kingmaker.
And this is the number that really drives that point home: 500. That is the total number of marks for your optional subject, spread across 2 papers. In a competition where a single mark can change everything, 500 points is, well, it's a massive piece of the pie. It's where the top rankers really pull ahead, and honestly, where a lot of dreams can fall short.
Okay, so with that much riding on it, let's break down exactly why this is such a high-stakes decision. This isn't just about picking a subject you kind of like. It's a huge strategic move you have to make.
Just let that sink in for a second. A 1% difference in your marks, that's just 5 marks out of 500, could mean jumping up or down 100 spots in the final ranking. It's just a brutal reminder of the razor-thin margins we're talking about here. And with physics, that means every single calculation, every step in a proof, carries enormous weight.
So, if the stakes are that high, why would anyone willingly choose a subject as famously difficult as physics? Well, the answer is that it has a unique edge. So let's look at the actual arguments for why you'd pick it.
This chart tells a pretty amazing story. Every single year, about 10% of the candidates who choose physics as their optional score above that magical 50% mark. Now, compare that to other subjects where that number is usually less than 3%. To give you some perspective, scoring 50% in this exam is considered a massive achievement, and physics, year after year, produces the highest percentage of these top scores.
So this really points to 2 different ways of thinking about it. On one hand, you have the pragmatist. They look at physics and see a stable, objective subject. Your answer is either right or wrong, which makes the scoring really predictable. Then you have the purist who says, look, you can't fake it. You have to have a genuine interest to get through something like quantum mechanics. And the truth is, to succeed, you probably need a little bit of both. You need the strategic mind and the real passion for the subject.
All right, so what does this beast of a syllabus actually look like? I know it can feel overwhelming, but like any big problem, you just have to break it down into smaller pieces. Let's map out the territory, starting with paper 1.
So paper 1 is all about the classical world of physics. This is the bedrock, the foundation laid down by the giants. Think Newton, think Maxwell. It's all the physics that really defined our world right up until the 20th century.
Section A kicks off with the absolute cornerstones. You've got classical mechanics, which is all about motion, and then Einstein's special relativity, which completely changed how we think about space and time. From there, it's into the behavior of waves and the science of light, which is optics. Then, Section B continues that classical journey. You're diving into electricity and magnetism, Maxwell's equations, and then you move into thermal and statistical physics, which gets into the fundamental laws of energy and how big groups of particles behave. Okay, so if paper 1 was the foundation, paper 2 is the revolutionary, mind-bending skyscraper they built on top of it. This is the modern world of physics. These are the discoveries from the 20th century that turned everything we thought we knew completely on its head.
And Section A throws you right into the deep end with quantum mechanics. Yep, you'll be tackling the Schrödinger equation, the whole weirdness of wave-particle duality, and then you'll see how all these bizarre ideas apply to atomic and molecular physics.
And Section B finishes off the map by going right into the heart of the atom with nuclear and particle physics. After that, it zooms out to the structure of materials in solid-state physics, and then wraps up with the practical applications that pretty much power our entire world in electronics.
So that's the territory. The big question now is, how do you actually conquer it? This is not just about studying hard. It's about studying smart. You need a real strategy. Let's get into the practical tools and tactics you're going to need.
I like to think of it as a 3-step process for building your arsenal. First, you've got to choose your guides. That means getting the right books. Second, you have to master your craft, which is the art of writing a perfect answer when the clock is ticking. And third, you prepare for battle through just relentless revision and practice. And here's a great place to start building that arsenal. According to the experts, these are the books you absolutely need in your toolkit. We're talking about authors like Griffiths for electrodynamics and quantum mechanics, Kleppner and Kolenkow for classical mechanics, The key here isn't to read a dozen different books for each topic, but to really truly master a few of these core texts.
Now, this is the kind of practical wisdom that comes from people who've actually cracked this exam. Rule number 1, cover 100% of the syllabus. No skipping chapters. Second, you need to aim for at least 4 to 5 complete revisions. Then, here's a crucial exam hack. For a 10-mark question, you get about 7 minutes, and it should never be more than 1 page. And finally, always try to add value with diagrams and by explaining the physical meaning of your answer.
All right, we've covered the stakes, we've walked through the syllabus, and we've talked strategy. Now, it's time for the final verdict. Let's bring it all together so you can make a decision that's right for you.
So it really boils down to this. The pros. Physics has incredible scoring potential. It's objective, and the marking is really predictable. But the cons are serious. The concepts are incredibly complex, you absolutely need a strong aptitude for math, and this is a big one. There's almost zero overlap with your general studies papers. That means you're preparing for it on a totally separate track. And that brings me to this last, really powerful idea one expert mentioned. Tapasya. It's a Sanskrit word, and it doesn't just mean hard work. It's about a period of intense, deep, almost meditative focus. For someone preparing for physics, this means something very specific. 10 hours of non-stop focused study every single day for 6 months. It's more than just studying. It's a completely transformative process. And so that leaves us with the final and honestly the most important question, and it's one only you can answer. Forget the syllabus and the strategy for a minute. Do you have the physicist's mindset? Do you have the passion to actually enjoy this difficult journey, the mathematical brain to handle the complexity, and the discipline for the tapasya that it demands? In the end, that's really the only question that matters.